Alrighty, so in this unit, in this chapter, we're going to be looking at a variety of functions. And this first section is just kind of an overview, and it hits on a lot of vocabulary that we're going to use consistently throughout the unit. So starting off, we have what's called a relation. And a relation is a correspondence between two sets of data. So a relation is a correspondence between two sets of data. And when we're looking at graphs, a lot of times we're looking at points. So a relation is basically a set of all points. So another way to think of a function is, let's say we have a function machine, and inside it we have lots of calculations going on, like adding and multiplying and cubing and a lot of things happening to a number. The input is the number you put in the function, and the output is the result after all those calculations are made. So the output is the result. The technical definition of a function is, let's say we have two sets, x and y, and it says here that they're non-empty sets. That just means we have to have some kind of data in those sets. And a function from x to y is a relation, so it's a set of points that associates with each element of the x set. Each element of x goes onto exactly one element of y. So in more common terms, what I like to say is, for every x, there is exactly one y. So for every x value, there's exactly one y value. And some more descriptive words that we have are domain and range, and I think we've heard of these before. And the domain is all the possible inputs. All possible inputs. Okay, and we think of those as being the x values. And the range is all the possible y values or outputs. In this first example, we see two sets of data. On the left, we see it's got a heading of states, and it's listing some states: Alaska, Arizona, Colorado, California, Florida. And on the right set of data, we've got the number of representatives in the U.S. House of Representatives. So each state gets a certain number based on its population. So if we think of the states as our x values and the number of representatives as the y values, if we look at each state, let's look at Arizona. And Arizona is mapped to 8 representatives. So based on Arizona's population, it gets 8 representatives. Florida, based on its population, gets 25 representatives. All right, each one of these states is mapped onto a specific number of representatives. So is this a function? Yes, it is. And it's because each state has one specific number of representatives. It would be impossible for California to have 53 representatives and one representative. Okay, California is assigned one number of representatives, and that would be 53. In example 2, we see more sets of data. Right here, we have the education levels that people can attain. Some people don't get a high school diploma. Some people do just get a high school diploma. Some people have some college, and some people have a diploma or a degree from a college. And each one of these levels of education is mapped onto an unemployment rate. And for example, if you have a high school diploma, or if we look at the set of people with high school diplomas, it looks like we have about 5.9, is that what it is? I can't see it. About 5%, sorry, about 5% unemployment. So each one of these has one number that it's associated with in terms of unemployment. So that would be a function. And because it's a function, we want to state its domain and its range. So the domain is a list of all of these possibilities. So I'm not going to rewrite all of those, but that's our domain. And our range is a list of these possibilities. This is our range. But usually, if we have numbers, we want to list them in order. So usually from lowest to highest. So this would be 2.7, 4.2, 5, and 8.5. In the second example here, we have hamburgers from different restaurants, and those are our X values, and they are mapped onto the number of fat grams associated with the hamburger, and these are our Y values. If I look at these, Wendy's single has 410 calories, but that is 19 grams of fat. It goes from the hamburger to exactly one number, and each one of these is the same. Okay, so each one of the elements of hamburgers is mapped onto exactly one number for grams of fat. So again, this is a function. And again, I'm going to state this is my domain instead of writing them out again. And my range are the numbers in order, which are 19, 23, 24, 29, and 33. In example C, this shows us, it's labeled up here carats. So I am guessing that this is the weight of diamonds or some kind of gemstone. And this is showing that a gemstone with 0.71 carats is going to cost this much money. Okay, 0.73 or 73 carats is going to cost this much money. And if I go down, each one of these is mapped on to one number except for this one. This x value is mapped on to two different y values. They're saying that a carat of this weight has a cost of, I can't read those, it's so little, $3,209 and $3,097. So because I can see the arrows going to each one of these, and there are two different y values, this is not a function. And because it's not a function, we're not going to have to list the domain and the range. In our next example, we see a set of points. That is our relation. And to determine if this would make a function, what we have to do is look at the x values. And in a set of points, every x value has to be different if it's a function. So if it's a function, every x value is different. In part A, if I look at my x values, 1, 2, 3, 4. All of my x values are different, so this is a function. Its domain is a list of those numbers in order, 1, 2, 3, 4. And the range is the list of y values, which is 4, 5, 6, 7. Part B, the x values, 1, 2, 3, and 6. They're all different, so it's a function. The domain is a list of those x values, 1, 2, 3, and 6. And the range is a list of the y values. Our y values have 4 and 4, 5 and 10. If a number is listed twice for a y, that's okay. It's only the x values that have to be different. And if the number is listed twice as in 2 points, when we list the numbers in the range, we only have to list them once. We want to know what numbers are in the range. So 4 is in the range, even though it's there twice, and so is 5, and so is 10. In part C, x values, -3, -2, 0, 1, -3. So because my x values are the same in these points, this is not a function. Okay. And if I were to kind of draw a map of that, that would be showing -3 going to 9 in this first point and going to 8 in that last point. And -3 is not allowed to have two different y values. So this is not a function. If we see an equation, we want to determine a lot of times if equations are functions. So I'm going to look at my equation, y equals 2x minus 5. And I'm going to pick some values for x. And it doesn't matter what I pick for x. If I pick 0 and I plug it in, 2 times 0 is 0. And then minus 5 is 5. If I pick 1, 2 times 1 is 2, minus 5 is -3. If I pick 7, 2 times 7 is 14, minus 5 is 9. And no matter what I pick, I'm only going to get one value for y. Okay, I can pick a negative number. If I pick -4, 2 times negative 4 is negative 8, minus 5 is negative 13. So no matter what I pick, my y values, there's just one of them. And if we think about the definition of a function, for each x value, there's exactly one y value. So this is a function. And that's because for every x, there is exactly one y. Now the next one, we want to know if that equation is a function. And if you think back to Unit 1, where we had equations x squared plus y squared equals 1, hopefully right now you're thinking, oh, I know that's an equation of a circle, and it has radius 1, so this is a unit circle. Oops, I kind of missed it on that one. But this is a unit circle, my radius is 1. But if I look at my x values between 1 and negative 1, let's say I pick this x value of negative 1/2. If I look to see what y value I have a y value up here, and I have a y value down here. So in this case, because this x value goes to two different y values, this is not a function. And I know a lot of you are familiar with that famous vertical line test. If I were to draw a vertical line and it hits the function in more than one spot, we know it's not a function. That's the easiest way to tell if something's a function or not. So we're going to look at some notation of functions, and when we're looking at algebra and pre-algebra and algebra 2, most of the time we use y as our y value, as our output value. But as we get into higher level math, we're going to start using f of x. And it's the same thing. Y is the same thing as f of x. We would read this as y equals f of x, where x is the independent variable and y is the dependent variable. A lot of times I think of x can be anything. It's independent of anything else. But y depends on what x is. I pick an x, I plug it into the function, and depending on what x is, that's going to determine what y is. So that means y is the dependent variable. So in example 6, we have a function and it's defined it's defined 2x squared minus 3x, and they want us to evaluate. That's the same thing as plug and chug. So that means they want us to plug in 3 for x. This means what is the value of this function when x is 3? So f of 3 is going to equal 2 times what 3 is squared minus 3 times what 3 is. And if I do some simplifying, 3 squared is 9, so this is 2 times 9, minus 3 times 3 is 9. I have 18 minus 9 is 9. So when x is 3, the value of this function is 9. And that's the same thing as our y value. In part B, they're asking us to take the f of x function. So we're taking this and we're not replacing x with anything. We're going to keep x as is. And we're going to add f of 3 to that. So f of x is 2x squared minus 3x. And f of 3 we found over here is positive 9. So I'm going to add 9 to that. And that's what I have. This is f of x, and I'm adding f of 3. And there's nothing else that I can simplify here. In part C, they're asking us to take f of x and multiply the whole function by 3. So I'm going to start with 3, and I'm going to multiply that by 2x squared minus 3x. Now I just need to distribute. 3 times 2 is 6 with an x squared. And then I have minus 3 times 3x is 9x. And that's simplified. In part D, they ask us to find the value of the function when I take x and replace it with 3x. If I rewrite this function, I'm going to start with 2, and I'm going to group by using parentheses, and instead of x in those parentheses, I'm going to replace that with 3x. Then I'm going to subtract 3 times what x equals, which is 3x. First thing I have to do here is the exponents. So this is saying 3x to the second power. This is the same thing as 3x times 3x. A lot of times we'll square the x, but we'll forget about the 3. So this is actually 3x times 3x is 9x squared. I'm multiplying that by 2, and I'm going to subtract 3 times 3x is 9x. After this multiplication, 2 times 9 is 18, x squared minus 9x. Almost done for today. So in this example 7, it gives us a function, it defines a function, and our function is x squared. They ask us to use a calculator to plug in 1.234. So f of 1.234 is the same as 1.234 and square it. And when I'm using a calculator, it will give me a number with a long decimal. And that number is 1.522756. In our directions, it doesn't tell us that we can round to any place value. So we're going to leave it as exact as we can, and we're going to leave it as this number here. In part B, this time if you notice, they labeled our function g of x. It works the same way. Sometimes it'd be f of x, g of x, h of x, c of x. It doesn't matter what this letter is in front of x, but I'm looking at this function and I'm replacing x with 1.234. So I would say g of 1.234 is 1 over 1.234. Now we can think of this as two ways. We can think of this as division, 1 divided by 1.234, and you can press those keys in the calculator. Or we can think of this as the reciprocal, in which I would put 1.234 in the calculator first, and then push the button that looks like this. In either case, my answer would be 0.8103727715. And again, it didn't ask me to round to any given place value, so I'm going to leave it as exact. And I think we're going to stop here. We're going to take a break, and we'll have another video that will explain how to work with finding the domains of functions.